Hello everyone, I'm Syrus, and today we are chatting about WebAssembly in Web3. And basically, it's going to be a story tale on how Wasmer can help your ecosystem, especially if you are on the decentralized platform Web3 world. So, presentation about myself. I'm Syrus. I'm the founder and CEO of Wasmer. If you don't know what Wasmer is, we are a server-side WebAssembly runtime that basically allows anyone from companies to enterprises to blockchain applications, basically to anyone, leveraging on WebAssembly to run any kind of software anywhere in the cloud, in the edge, in blockchains. And you can find reference to myself and to the company in almost all the slides. So my email is syrus@wasmer.io, or Twitter is wasmer.io, and our GitHub is also wasmer.io. So that's a bit about myself. I'm from Spain, so that's why I have an accent. But yeah, I was gonna say that feel free to ask questions, but I think this is only one way. So I'm not sure if I'm gonna be able to see your questions. So let's start. The agenda for today. Today we are going to see why WebAssembly is important, especially for Web3. What are the challenges that you usually face, especially if you're trying to execute WebAssembly on blockchains? How Wasmer can help on those? And one of the things where I wanted to put more emphasis today is what is the state of the art right now regarding the ecosystem, and what the future entails. What are the next things that are coming in the Web3 WebAssembly world? So as probably most of you know, WebAssembly is emerging as the universal engine for smart contracts. There are right now multiple engines, especially on WebAssembly, that make that possible. And I'm gonna overview why WebAssembly is key for the Web3 world, for decentralized applications, blockchains, and so on. First is because it's a universal format that can run code universally. That means running code in any chipset, in ARC64 or ARM, in Intel chipsets, in RISC-V when the future comes, or any operating system, in Linux, Windows, iOS, Android, it doesn't matter. Also, one of the main advantages of WebAssembly is it can be fully sandboxed. And I'm saying it can be because it depends on you, but by default, it's secure by default. So unless we create system calls that are insecure, WebAssembly and the WebAssembly runtime will be fully secure. And one of the main advantages that we have on WebAssembly is because it is a very light abstraction on top of chipset instructions. It's really, really fast to run. So we get almost to native speeds, usually with a slowdown of 5 to 10%, and sometimes even with a speed up. So what are the challenges when running WebAssembly in Web3? These are things that probably you already know if you are using or executing WebAssembly on your blockchain, which is you can have JIT bombs. And what is a JIT bomb? A JIT bomb is a program that takes longer to compile than it takes to execute. And basically, with this, you can have a malicious actor that tries to get your blockchain down by sending you code that is gonna have a very big complexity when compiling. So basically, it might have O n square or n cube timings when compiling the module, and we don't want that. Also, one of the challenges that we have when trying to run WebAssembly across a heterogeneous infrastructure is that we want deterministic execution. So that means if I'm trying to execute a module that does operations on nonce, nonce are not a number, so kind of infinity or so on. So when we are doing operations over these numbers, or yeah, basically WebAssembly doesn't assure deterministic execution across chipsets, and usually what we want is deterministic execution. So that's one of the biggest challenges, and that's why in some runtimes usually they disable floats, which are what usually introduce non-deterministic behavior. Another challenge that you might have when running WebAssembly server side is that you want to scale as much as possible your WebAssembly modules, so you can run as many smart contracts as possible within your chain. So these are the main challenges when using WebAssembly in Web3. So now I'm going to be presenting Wasmer. Here is the marketing or my biased approach or recommendation, which is Wasmer is really an ideal runtime to execute WebAssembly on decentralized platforms. Why is it good for your ecosystem? First one is because we have a compiler that allows you to compile WebAssembly code in a way that is completely linear. So that means that like no matter if your module like weighs 1 megabyte or 10, it's always going to compile at the same speed, which is usually like 5 megabits per second. Obviously, like depends on your mileage and how powerful your chip is. But like the compilation is fully linear. That means that like you are not going to see O(n) square complexity when compiling, which usually means that you're going to get into compiling certain kind of programs much faster than other optimizing compilers, such as CraneLeaf or LLVM. On one side, I have to say CraneLeaf is not really like an optimizing compiler, or at least it's not at the level of LLVM. But we have seen some cases where CraneLeaf, for example, takes 1 minute to compile, and single pass takes just a few seconds. So in general, like usually you want a compiler and a runtime that is not prone to JIT bumps, and for that, Wasmer is really good. The other thing that we have is deterministic execution across chipsets and platforms. So that means that when you run a WebAssembly module in Windows, it's going to run exactly the same way. It's going to give you exactly the same input, same output for the same input. So this is quite important, and we have like a lot of tests assuring that. And one of the things that we have been like very focused on since the beginning is to have the platform to be fully highly scalable. So on that front, yeah, we have optimized a lot. The startup time is just a few microseconds. And we offer the developer and the company or the blockchain like different alternatives to play with to ensure that you get the maximum performance. So let's continue with who's using Wasmer. So we got Near Protocol, Cosm, Wasm, and Space Mesh. This one I want to kind of like highlight those, especially because they are sponsors of the open source project. They are collaborating with a sponsorship to make sure that like the Wasmer evolve at a healthy place, and also to make sure that we have features that they may need. But apart from that, from them, there are tons of other blockchains that are already using us. To put some examples here, we have Fluence Labs, Holochain, ChainSafe, Elrond, Parity, which are just like trialing Wasmer, and the Band Protocol. So these are some of the blockchain ecosystems that are using us, but not all. Actually, like I discover a lot of new ones each week, and more or less like this one are the most well-known ones. So what we did with the sponsorships, I'm here trying to attract you to collaborate into the ecosystem if you believe that like WebAssembly is a key part of your infrastructure on the decentralized world. So we optimize for startup speed. We lower it from a few milliseconds to just some microseconds. So that was a high improvement. We optimize for really fast completion times. So in the case of single pass, we did like a 4x improvement on the speed when compiling. Of course, if you use parallel processes or threads. And one of the things that we did lately is making Wasmer fully usable in the browser. So what this means, if you have a Rust program that is using Wasmer under the hood, before you were only able to use your Rust program in native executables. Basically, like you compile your program natively, you try to execute it, and then like basically Wasmer runs under the hood. One of the nicest things that we did in Wasmer 2.1, which is not yet released, but it will very soon, is that we allow your Rust program to compile to WebAssembly through Wasm bindgen without any syntax change. So you can, when using Wasmer in your Rust program, you can target the web or you can target the server. It really doesn't matter. And this is quite big, especially for what we believe is gonna make users use Wasmer in a lot of new places. So what is coming next regarding Wasmer, the runtime? First is, thanks to the sponsorship of Custom Wasm, we have been working on full ARM support. We are still on the way on developing this one, but yeah, we are getting very interesting results right now, and we'll say we are 30–40% on there. Other thing that I'm super happy to announce is that as of today, we just merged support for single pass in Windows. I'm not sure if Aviv from SpaceMS knows this yet or not, but basically we added full support for single pass, and that means that when using single pass in Windows, you can basically you can execute Wasmer with single pass, which is awesome. Other thing that actually Near protocol has been working with is on adding signal-less support. This support right now is quite experimental, and we have not merged it yet, but it's on the way of basically making it work and trying to get the findings. Also, we want to have very easy, usable, and pluggable WebAssembly modules from different languages, which means we want to add support for interface types, and we are actively working on this. Also, we are working on a new cross-chipset architecture, which is basically refactoring single pass to make it much more scalable across different architectures. So let's look into the cool things. What is the state of the art? Where are we at right now? And this is not regarding Wasmer, but regarding WebAssembly. What are the different cool things that are happening on the ecosystem? First one, let's talk about the SDKs. I've been watching what Fluence is with their framework, which I forgot their name. And it's not very different from what Definity, for example, is doing on Candid. So basically what I'm gonna say is probably that applies the same for the framework that Fluence Labs has been working on. So with Definity Candid, which I think is a very original approach, it allows you to create universal SDKs that can run on Definity Internet Computer. This is basically more or less a precursor to interface types, which allows you to create universal APIs that can run in any language. I just remember what was the name of the framework from Fluence, which was Marine. So Definity Candid, I think, is very similar to Marine. But there is one thing that I think is very interesting about Candid, which is formally verified, which I think is quite important, especially for blockchain or decentralized applications, and also is uniqueable, hashable. So I would recommend you to take a look on the project. They have support for multiple bindings, and I think it's just the beginning. Probably this is gonna feed back into what interface types is gonna become. But Candid is a pretty good approach, and probably the one from Fluence as well, although I didn't have as much time to review it. Yep. I think I deleted the wrong slide. So in here, I was supposed to talk about the compiler, and I remember. So I'm just bear with me about what I'm gonna say. So we have discovered a very novel approach for compiling WebAssembly code back to machine code in a way that is super fast. So right now, with single pass, we are generating the code at runtime, and we are detecting what are all the different WebAssembly operations, and we are generating the machine code related to these WebAssembly operations at runtime. This is great, but we can get much better when generating the code at runtime, and as well to generate code that is more or less optimized. So by using a novel approach that relies on the LLVM compiler, we can get LLVM to do that ahead of time for us for each of the WebAssembly operations. So then the compiler only needs to patch the location of the addresses, and that's it. I'm sorry about the slides. I will upload them later, and it will have this slide fixed. So one of the things that I remain super excited is what's going to happen in the future. Not just like where are we at right now, but what are the interesting paths that we will see in the future. So here are some of the ones that I remain most excited about. First one is universal smart contracts. I think that thanks to interface types, we can allow developers to create smart contracts in any language. So basically like Marine with Fluence, Definity with Candid, and interface types in general are going to be really key to create universal SDKs that allows us to run smart contracts cross-chain. This, of course, will depend on the blockchains to decide on common SDKs that can be usable. But I think there is a very good and potential opportunity for almost all the chains to agree on a API that is going to be universal across smart contracts. I think this might take some time, but I remain very excited about this one, especially because when you create a smart contract, you might be able to execute in one chain or the other. Other feature that I remain very excited about is pause and resume. So what this means is being able to pause our virtual machine as it's run with the WebAssembly module and restore it anytime after. So why this might become important? As a smart contract get more powerful and we can do more things with them, we might need to execute the smart contracts that are becoming more and more complex. So for example, in the case of Definity Computer, they are starting to allow, I believe, like some pausing modules, but basically like you are gonna get more contracts that are more complex and complex over time. And it might become very interesting to be able to pause a smart contract, perhaps like when a node becomes like very overbooked, and being able to translate or to move that execution towards other node. Or perhaps just kind of like being able to recover state from a partially executed contract because something happened on the node. So I think this feature is super exciting. We are looking forward to support it at Wasmer, and I think it's going to help a lot on the blockchain ecosystem as well, or web3 ecosystem. And here is one of the future things that I think are going to happen that I really remain super excited about, which is IPFS. So I'm going to do a demo, not a demo that I have created, but I'm going to do a demo in a few minutes on like what this thing commenting. But basically like the main thing that this slide is trying to entail is that we can use IPFS as the distributed file system for both distributing the contracts or the applications that we want to execute, and also to distribute the storage that this application might use. So sometimes applications like such as Rust applications, they might not require any like file system, but if we try to run like more complex examples, like let's say Python relies in a lot of like files or system files that are actually required to be able to run the runtime successfully. And leveraging IPFS to be able to run this module across basically like anywhere, I think is super interesting. So in a few minutes, we are going to see an example of how, for example, run a decentralized Wikipedia search. And this is going to be executed in the browser, but it's going to showcase like what are the different opportunities on the space. So bear with me. I'm going to try to share my whole screen in a second, and let's see if I get it right. Awesome. So I'm gonna share my screen again, but I'm gonna share other screen. So here we are. Probably you're seeing my browser. You will like what I'm gonna demonstrate is a full text search on Wikipedia, and that means kind of like a very large database, like gigabytes of database. And here we are gonna try to execute search on this data set, which is super, super large. So let's try to search for Wasmer. I'm just curious how, like, what's gonna happen. Cool. So it's funny. Not sure what are all these different articles, but we can see that like Wasmer got searched in a lot of appeared in a lot of like different articles. Let's actually like search for WebAssembly here. So we can see that like we were able to execute the logic in my computer, but the storage is somewhere else. So let's inspect about like what is happening here underneath it. I'm gonna search again so you can see the requests. Let's reload. Yeah. So basically, like what is happening here is locally the module is requesting kind of like the very big data set, and usually like what happens when you search on databases is you don't get the whole database in memory. Usually like you search at the beginning the indices, the index, to see like where certain words might appear, and then based on different indexes you do like you seek that file to get into that specific content. So you say there might be an index saying like, oh, this word appears in this offset, in this other offset, and this other offset, and then basically like you search on all of them, you get more indices, and then like you kind of like the engine merges them together. So in this case, there has been like 28 requests that like come when we try to search for Horace Slughorn. And this is basically like what it's doing is retrieving the storage from somewhere else, but it's executing locally. So this is one of the examples that I think is going to become very key. For example, to have like search on IPFS on the Wikipedia, but not just that, but also to be able to run like, for example, Python, but where the file system is completely distributed. So that's one of the examples that I'm most excited about. And this is so far kind of like as far as we can get on the presentation. I'm gonna jump into the last slide. I'm not sure if it's worth for me to share or not, but I'm gonna do it. So yeah, just basically like that was the presentation. It's a little bit shorter than the rest. I wanted to keep it lean, short, and basically focus more on what are the exciting things that I think are gonna happen in the future. So having said that, does anyone have any questions?